Zinc is the chemical element with the symbol Zn and the atomic number 30. That means that a zinc atom has 30 protons and 30 electrons. Each element is identified at room temperature and pressure as being a solid, a liquid, or a gas. This is referred to as the element's states of matter. Zinc's state of matter is solid. It is a bluish, white, and silver metal which is often used to galvanize other metals such as iron, preventing it from rusting. For zinc to become a liquid, it has to reach a temperature of 419.5 degrees Celsius, which means that zinc has the lowest melting point of all the d-block metals aside from mercury and cadmium. This is one of the reasons why zinc, cadmium, and mercury are not always considered to be transition metals like the rest of the d-block metals are. Galvanized steel can be used for car bodies, lampposts, or safety barriers. Zinc oxide, which is an inorganic compound between zinc and oxygen, are used in a lot of materials and products such as rubbers, plastics, cements, paints, ointments, pigments, batteries, and much more. Biologically, zinc is essential for the human body. It is very important because it is found in every tissue in the body and is involved with our cell division. Zinc helps to prevent cancer and helps us maintain our hormone levels. If we don't get enough zinc, both men and women can get infertile. Zinc is found in foods such as beef, seafood, spinach, nuts, beans, and many others. It is the 24th most abundant element in the Earth's crust. It has many uses and is the 4th most common metal used for industry right after iron, aluminium, and copper. It's essential for our health and it's a metal we encounter every day even though we don't necessarily think about it. Zinc is located in the D block of the periodic table, which is called the transition metals, and it is in the same group as cadmium, mercury, and carbonetium, which means that these elements have the same chemical properties and they all have 2 electrons in the outer shell. Zinc is in the 4th period, which tells us that it has 4 shells in total. By using the formula 2 times n to the power of 2, where n is the shell number, we can calculate how many electrons there can be in each shell. In the first shell, there can be a total of 2 electrons. In the second shell, there can be 8 electrons. In the third shell, there can be 18 electrons, and so on. In this shell model of zinc, you can see that it has 30 protons, 30 electrons, and it has 2 electrons in its first shell, 8 in its second shell, 18 in its third shell, and 2 in its outer shell, just as we calculated before. Most chemical elements in the periodic table would like to fulfill the octet rule. The octet rule, also called the noble gas rule, says that the elements want to have 8 electrons in their outer shell, just like the noble gases. The noble gases are located in the 18th group in the periodic table and are unable to react with the other elements. This means that they are inert. But transition metals will not always follow the octet rule. Because zinc has 2 electrons in its outer shell, it would often want to donate these 2 electrons and thereby becoming a zinc 2 ion. This is an atomic ion because it only consists of an atom and a charge. Polyatomic ions are ions that consist of more than one atom and a charge. That could, for example, be nitrate, which consists of one central nitrogen atom surrounded by 3 oxygen atoms. By looking at the periodic table, we can also tell the atomic mass of the elements. The atomic mass in the periodic table is the average atomic mass of all the elements' isotopes. An isotope is different versions of the same chemical element where the number of neutrons varies. The naturally occurring zinc is composed of the 5 stable isotopes: zinc 64, zinc 66, zinc 67, zinc 68, and zinc 70, with zinc 64 being the most common. 49.2% of the zinc isotopes are zinc 64. 27.7% of the zinc isotopes are zinc 66. 18.5% of the zinc isotopes are zinc 68. 4% of the zinc isotopes are zinc 67, and 0.6% of the zinc isotopes are zinc 70. When we have these numbers, we can calculate the weighted average atomic mass for zinc, which is 65.38 atomic mass units as we saw in the periodic table. By using the formula A equals Z plus N, where A equals the number of nucleons, Z equals the atomic number, and N is the number of neutrons, we can calculate the number of nucleons in zinc. We can replace Z with 30 because we already know that zinc's atomic number is 30, which also means that there always will be 30 protons in a zinc atom. Because the atomic mass for zinc is 65.38, and we know that a proton and a neutron each weigh 1 unit, that must mean that there is 35 neutrons in zinc, because 65 minus 30, which is the weighted average minus the protons, equals 35. And that means that there in zinc is 65 nucleons. In this experiment, we're going to see how zinc and hydrochloric acid reacts. And first, he takes a solid piece of zinc and puts it in a test tube filled with some hydrochloric acid. And you can see that the solution starts to react and it starts to bubble, which means that a gas is being released. And in this case, the gas is hydrogen. And after that, he takes a balloon filled with zinc powder and pours that into some hydrochloric acid in a new flask, and he secures the balloon at the top. And by doing this, he is capturing the hydrogen, and now we're able to see how much hydrogen is actually being produced. The chemical equation for this reaction is written here, and we can see that what happened was that when zinc and hydrochloric acid was mixed together, it reacted and made hydrogen and the salt zinc chloride, which is made of the metal zinc and the nonmetal chlorine. Zinc and the hydrochloric acid on the left-hand side are the reactants, and the hydrogen and the zinc chloride on the right-hand side are the products of this reaction. But because there is more chlorine and hydrogen on the right-hand side in the reaction scheme than there is on the left-hand side, this is not a balanced equation yet. Therefore, for this equation to be balanced, we put the coefficient 2 in front of the hydrochloric acid on the left-hand side, and now the equation is balanced.